Hello, my name is Shuhong Chen. I'm a PhD student at the University of Maryland, College Park, working with Professor Matthias Zwicker. I'd like to present our WACV 2022 paper on transfer learning for pose estimation of illustrated characters. 2D human pose estimation is a foundational computer vision task with many real-world applications, such as activity recognition, 3D reconstruction, motion tracking, etc. However, the usefulness of pose estimation is not limited to the natural image domain. A pose estimator for illustrated characters may serve as a useful prior for downstream non-photorealistic tasks, like illustration colorization, character reconstruction, animation keyframe interpolation, etc. To perform pose estimation on illustrations, we follow prior work by Kungern et al., who introduced the Anime Drawings Dataset, or ADD, for illustrated pose estimation. They performed sim-to-real transfer learning from another synthetically rendered anime pose dataset and applied deep transfer learning from an image classification feature extractor. However, there are several limitations to their work. The ADD dataset was missing key points and bounding boxes required under the more modern COCO standard, and overall lacked pose variation. In addition, they did not transfer learn from any pose estimation model, used a feature extraction backbone trained on natural images instead of illustrations, and were not able to release their synthetic dataset. We face these challenges by extending the ADD dataset and implementing more effective transfer learning, resulting in a state-of-the-art illustrated pose estimator that significantly outperforms Kungern et al. And allows for the novel application of pose-guided illustration retrieval. We first fix ADD by making it COCO compliant. In particular, we manually label the missing eye and ear key points on all 2,000 samples, making it compatible with many modern pose estimators. However, to allow evaluation with the popular COCO OKS metric, we must also provide character bounding boxes. To this end, we train a character segmentation model and produce the box annotations by bounding the predicted segmentation. To train the segmenter, we collected a new dataset of alpha compositable characters filtered from the Danbrew image board, making our dataset 20 times larger than the currently available AniSeg. Fine-tuning a DeepLab version 3 segmenter on this data also achieves state-of-the-art on single character segmentation. Next, we tackle ADD's lack of variation by adding an additional 2,000 samples. These were selected from Danbrew with difficult back-related tags. Here are some challenging new poses that were added to the dataset. Kungern et al. Also do not perform transfer from another pose model, and use a feature extraction backbone trained on natural images from ImageNet. In contrast, we propose a feature concatenation architecture as well as a more efficient feature matching architecture that leverages knowledge from both a task-specific MaskRCNN pose estimator as well as from an illustration domain-specific classification backbone. This classification backbone is a ResNet 50 trained to perform multi-label classification on Danbrew illustration tags. Instead of using available Danbrew taggers like RF5, which were naively trained on a long-tail distribution of tags, we train on a new 1062 class rulebook of manually filtered relevant tags, and use inverse square root loss reweighing to stabilize training. The drastically reduced class imbalance results in state-of-the-art classification performance and also provides a significant boost to pose estimation performance. Lastly, while Kungern et al. Were unfortunately unable to release their data and code, we make all our data and models publicly available for the research community. With our methods, we achieve state-of-the-art pose estimation of illustrated characters. Due to key point incompatibilities, we may only compare PDJ as reported in Kungern et al., but as we see in this table, we are able to outperform their model by a significant margin of roughly 10 to 20%. We also provide comprehensive ablations of our model components. Please see our paper for more details. Finally, we apply our state-of-the-art character pose estimator to the novel task of pose-guided illustration retrieval. Given a query image, we can extract its pose and find nearest neighbor images based on relative key point positions. This may be useful for artists who often search for reference materials when drawing difficult poses. Here we show a more complex jumping query. We can also find popular poses, such as the Wariza or W sitting position. While our system has no awareness of perspective, it is able to effectively leverage key point cues to retrieve similarly foreshortened views in this example. This concludes our presentation of transfer learning for pose estimation of illustrated characters. Please feel free to reach out to us at the University of Maryland, or check out our GitHub at shuhongchen/bizarre pose estimator. Thank you for your attention.